Hey everyone, and welcome to this explainer. Get ready, because today we're embarking on a cosmic journey into the universe's most terrifying, mind-bending, and honestly, utterly fascinating phenomenon. We're going to be looking deep into the abyss at something that just constantly baffles astronomers and completely challenges everything we thought we knew about physics.
You know, whenever we talk about the cosmos, these really wild questions start swirling around. We've all heard the popular sci-fi myths and stories, right? The idea that falling into a black hole might transport you to a brand new universe, or maybe it's a place completely beyond the reach of time, where death doesn't even exist. Some folks even think they're literal gateways to God. And hey, it's incredibly tempting to romanticize the unknown. But today, we're going to ground ourselves in the astonishing and, frankly, much more terrifying reality of what the source data actually tells us.
So the crucial point is this. At its absolute core, a black hole is a region of space packing the highest concentration of gravity in the entire universe. It just pulls in everything that crosses its path. And when we say everything, we literally mean everything. Not even light, which is the fastest thing in the universe, can escape its grasp. Once something goes in, it never, ever comes out. That's exactly why it's known as the point of no return. It's this place of absolute darkness where standard physics, yep, even Newton's fundamental laws of gravity, just completely fail and break down.
Okay, so here's our flight plan for today. We're going to start with the darkest cosmic mystery, then move on to the architecture of a black hole. From there, we'll break down the mechanics of the event horizon, experience the spaghettification experience, talk about local threats in Earth, the sun and doom, and finally, look beyond darkness to the white hole. Let's get right into it.
Section 1. The darkest cosmic mystery. So, how did humanity actually figure out that something this invisible and dark actually exists out there in the universe? Well, to answer that, we've got to rewind to the 20th century. In 1916, this brilliant scientist named Karl Schwarzschild used Einstein's general theory of relativity to pitch a pretty radical idea. He said, hey, if you take a massive amount of matter and compress it, like imagine shrinking our entire Earth down to a tiny, impossibly dense fraction of its size, that extreme compression theoretically creates a black hole. Now, get this. At the time, people essentially treated this like a math joke. It was just a wild fairy tale. That is, until 55 years later. In 1971, the very first actual black hole was discovered. It was highly compressed and sitting 6,000 light-years away from Earth. To put that into perspective, the light from the stars around it took 6,000 years traveling at the universe's absolute speed limit just to reach our telescopes.
Section 2. Architecture of a black hole. Okay, let's dive into this and shift our focus to the sheer physical scale and structure of these things.
Since that first big discovery in '71, scientists have identified 4 distinct classes of black holes. And honestly, the scale difference is just mind-boggling. First off, you've got miniature black holes. These little guys are the size of a single atom, yet they pack so much punch they could effortlessly swallow an entire mountain. Scientists think these are ancient leftovers from right after the Big Bang. Then you've got stellar black holes. These are 10 to 25 times the mass of our sun, born from a supernova, which is the ultra-bright explosion of a massive dying star. Next up are the intermediate ones, which happen when a bunch of those stellar black holes crash and merge together. And finally, the undisputed heavyweights, supermassive black holes. These form during the birth of galaxies themselves and weigh in at literally billions of times the mass of our sun.
4 million. I really want you to just let that massive number sink in for a second. This is the size multiplier of Sagittarius A star. That's the supermassive black hole hanging out right at the absolute center of our very own Milky Way galaxy. It is 4 million times more massive than our sun. It's a scale that is kind of impossible for the human brain to truly comprehend, right?
Section 3. Mechanics of the event horizon. Now this brings up a fascinating logistical problem. How do we possibly see something that is fundamentally invisible and literally swallows all the light around it? Well, the black hole itself is completely invisible, but we can actually spot them thanks to something called the accretion disk. See, when a black hole tears apart and devours a star, all that leftover dust and gas starts violently swirling around the edge. It heats up and glows incredibly bright. This glowing accretion disk is basically our only visual clue to the terror lurking inside, because right inside that glowing ring is the event horizon. That's the pitch-black inner boundary. It acts like a blind well. Once anything crosses that specific threshold, there's absolutely zero return.
And to safely observe this kind of violent cosmic architecture, we have to rely on some pretty amazing tech. NASA uses the James Webb Space Telescope, or JWST. To keep it safe and fully functional, it actually sits a staggering 1 million miles away from Earth. From way out there, it acts as our most powerful eye into the deep, dark mechanics of the universe.
Section 4. The spaghettiification experience.
And this brilliantly illustrates the physical mechanics of what would actually happen to you if you were unlucky enough to fall into one of these things. It's scientifically referred to as the spaghettification effect. As you get closer to the black hole, the gravitational pull on your feet would be vastly stronger than the pull on your head. The gravity is just so fiercely extreme that it would violently stretch your entire body out into a long, thin noodle shape before ultimately tearing you apart at a subatomic level. So yeah, definitely not a pleasant way to go.
But wait, it gets weirder. Before you're spaghettified, you'd experience a total breakdown of time itself, which we call time dilation. Just imagine placing a video call from the edge of a black hole back to a friend on Earth. As you fall in, you'd look at your screen and see your friend moving impossibly fast, like someone put their life on fast forward. But your friend, watching you from Earth, would see you moving incredibly slowly, basically frozen in time. It's a really beautiful but entirely terrifying illustration of how black holes warp the very fabric of reality.
Section 5. Earth, the Sun, and Doom. Let's talk about our own solar system for a minute.
I want to bring this a bit closer to home and debunk a few common myths about our own planetary destruction. First off, take a breath, because our sun is actually way too small to ever become a black hole. It just doesn't have the mass. In about 5 billion years, it'll just expand into a red giant and cool off into a white dwarf. But let's play with this hypothetical scenario anyway. If our sun magically transformed into a black hole of the exact same mass right this second, what would happen? Well, step 1, surprisingly, the planets in our solar system would actually keep orbiting totally normally. The gravitational mass hasn't changed, only the density has. But step 2, the sunlight would vanish entirely, which leads to step 3. Without that heat and light, life on Earth would quickly freeze solid and it would all end in the dark.
Now, what if Earth itself got sucked into a roaming black hole? The source material tackles this with a bit of dark humor, hitting us with this quote, "If Earth falls in, it gets shredded to pieces. The myth that a black hole is a gateway to God is only true because it means certain death." It's a stark reminder, for sure. Earth's gravity is literally nothing compared to a black hole. Our entire planet would be effortlessly torn apart. Remember, to escape a black hole's pull, once you cross that event horizon, you would have to travel faster than the speed of light, and based on everything we know about physics, that is absolutely impossible.
Section 6. Beyond Darkness, the White Hole. Let's move to this and see how this builds into something totally mind-blowing. We are stepping right onto the edge of the completely unexplored theoretical frontier of modern astrophysics here. Science is always evolving, right? I mean, before 1971, black holes were just theoretical math on a chalkboard. Well, today, scientists are predicting the existence of the exact inverse, the white hole. This is a theoretical object that nothing can enter, and it continuously, violently expels matter and energy out into the universe. We haven't actually seen one yet, but mathematically, they're predicted to exist. So if black holes are the most dangerous destructive entities we've ever found, just imagine what happens when we finally encounter a white hole. Is it going to rewrite the laws of physics all over again? I want to leave you staring into that abyss of the unknown today. Thank you so much for joining me on this explainer. Keep asking questions and always keep looking up.